Hello, good afternoon, guys. Please tell me if you can hear me. Thank you.
We can hear you.
Yes, you're audible.
Thank you. Sorry, I'm just checking my microphone. I'm not the instructor here.
Hello everyone, it's Ibrahim Abu Talib from Reservoir Solutions. Welcome to our webinar, Practical Data Analysis and Machine Learning for Petroleum Engineers. Let me introduce our company. Reservoir Solution is a company specialized in providing technical studies and courses for oil and gas companies and professionals. This company incorporates many professionals with diverse technical background related to oil and gas exploration. Our service is the technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researchers, assisting in writing technical papers and publishments, technical petroleum courses by industry experts, and providing mentorship programs. Let me introduce our instructor, Engineer Ahmed Abdel Gawad. He is a reservoir engineer at NBC Energy Ltd. Company. He is a Python developer and a data analyst and machine learning developer. He has certificates in field of data science and machine learning, like deep learning specialization, applied data science lab. Our upcoming course is practical data analysis and machine learning for petroleum engineers that will be held on 2nd July 2025. After the course, you will gain skill in data analysis, visualization, and machine learning tailored on to oil and gas workflows. Apply practical techniques to upstream problems with realistic datasets. Hands-on use of tools such as Pandas, NumPy, Matplotlib, Seaborn, Skit, Learn, Streamlit. Our webinar rules. You can ask your questions in the chat box and the WhatsApp group. Mute your mic and the camera. Fill in the form which will send to the WhatsApp group after the webinar to get your webinar certificate within 1 week, inshallah. Join our Telegram channel for upcoming webinars and courses. And this mail and WhatsApp is for our country. You can contact us to ask for anything about the webinars or the workshops. Mr. Ahmed, you can start now.
Oh, can everyone hear me right?
Yes,
Yes,
we
we
can
can
hear
hear you. Yes.
Yeah, I'm sorry for this. So, I'm Ahmed Abdel Gawad, a reservoir engineer at MPC Energy. I'm a Python developer and machine learning developer. I will provide the slides for you as an PDF format so you can review the content. You can reach out if you have any questions. I have LinkedIn, GitHub, YouTube channel for Arabic listeners. It will be for English in the coming days. And I have Medium articles. You can reach out via my website. So from the beginning, what is this workshop about and what is it is not? So I will explain the basics of machine learning, only the basics, like what is machine learning, the data science life cycle, the supervised and unsupervised machine learning with an example. It can be treated as a dummy example just to show the concepts. We will practice with no code software, which is called orange data mining. What I will not do is to go deep in any details. I will not explain any machine learning model and how it works. Okay. There is actually a problem, which is a gray box in the screen blocking some content. So, is it okay now?
Yeah, it's better.
Okay, so what I will talk about is what is data science life cycle, what is machine learning workflow, when and when not to use machine learning. Let's start by data science life cycle. So data science is a science that combines three major sciences: the mathematics, statistics, computer science, and domain expertise. So it is like an equation. You need to understand mathematics, computer science, and you need to have domain expertise in order to apply data science skills in a meaningful way. Any data science project or any data science life cycle start with a question or with a problem that you need to solve using the data. So it is a combination between the data and science. Let's say you need to build a machine learning model to predict, like in our case today, to predict the porosity, you to have a continuous log of the core porosity using the open hole logs. So it's a problem that you need to solve. Without the problem, you will not know how to apply these steps correctly. So you have a problem that you need to solve. You will start by collecting the data accordingly to this problem that is relevant to this problem. There are two types of data, which is unstructured and structured data. I will explain this in the coming slides. After collecting the data, you need to do some data preparation. So in order to have a clean, high quality data set, this step is very crucial and very important in order to build reliable model or reliable output. Without, without this step, it will be garbage in, garbage out. So this step is the most crucial step between all the steps of data science. After this, you can do some data exploration and data visualization in order to investigate the relationship between the features, the causality, the relationship, some type of visualization that make you understand something in a very simple words. And then you can build your predictive models or your statistical models or your dashboards that deliver a meaningful output. So this step is actually done after three previous steps. And without the three previous steps, it will be nothing and it will be garbage in, garbage out. And most of the tutorials focus on this step only, which will be experiments and building the models. But in real life, in order for you to apply these techniques, you will struggle with the three previous steps mostly. So what are the types of data preparations that we can do? It is like if there is any anomaly in the data, if there is missing data, how to deal with it. If there is any typos in the data, if there is outliers, which is equal to anomalies, if there's some features that need to be deleted and so on. Data preparation is so important. And the data science, as we said, is a combination between the data and science. The data need to be in high quality, and the science also need to be applied in a reliable way. And the data science in real life, it's a tool. So you need to have domain expertise in order to apply this tool correctly. So it is like you are a reservoir engineer. You have a problem that you faced and you need to solve it. You have data enough in order to solve it using the data science skills. So you know the problem well because you are a reservoir engineer, you have your domain expertise, and you understand how the tool works and how to apply it. So it's a combination between both of them, and both of them are crucial. This is simply the data science life cycle. Is there any question? All right. It will be very fast. So now, what is machine learning? Machine learning is subdivided into supervised, unsupervised, and reinforcement learning. We will understand what is supervised machine learning and what is unsupervised machine learning. We will not talk about reinforcement learning. It is a very unique topic, and it is pretty different from the two supervised and unsupervised. So now we are going to talk mainly about the first type of machine learning, which is supervised machine learning. Supervised machine learning, as the name implies, it have a supervision. It is like the human teaches the computers or teaches the algorithms, and the algorithms will understand the data and will work on it. It is like that the human will give data labeled to the algorithms. The algorithms study by themselves in order to answer any question imposed by their teacher. It is a little bit vague here, but we will explain this using our example. So we have open whole log data. It is pretty basic. Anyone can understand this example. We have the open whole log data, and we have core samples taken within certain depths, and we measured the core porosity. So in this problem, we are trying to predict the core porosity using the open whole log data to have a continuous log in all wells. So the input here is the open hole log. The output here is the core porosity. The basic or the traditional way to do this is that we can estimate the porosity using like the density log. If we have an estimation of the matrix density and the row bark is the density log, and we have an estimation of the row of the fluid, then we can estimate the porosity. It is like this. We have inputs, we have rules or equations, and then using them, we have the output, which is the core porosity. But machine learning work the other way, that you have the inputs and you have the actual outputs. The model itself will be the rule or will be the equation itself. So the model will be trained over the inputs and the outputs in order to give the inputs after that, and it will predict the outputs. So simply, the traditional thinking or the traditional programming is that you have inputs, you have rules or programs, and then you produce the output. But using machine learning, you have the inputs and you have the outputs. By combining them, you will create a rule or you will create a program, which is basically the machine learning model. Any questions so long? How to check availability of data. It is outside the scope of this talk. There is data preparation and data pre-processing. So outside the scope of this, let's start, or let's follow the simple workflow. Yeah. Is anyone trying to speak?
Yeah.
Yeah, okay.
Okay. So for the machine learning, we have an input and an output. So we already know the solution to what we are looking for. Is that what you mean?
We don't have
Because in the traditional method, okay, we are solving for porosity. So we have the input and we know the rules to follow to find our porosity. So using machine learning, what do we do? We already we have the input, and for instance, we already know the porosity that we are looking for.
I understand your point. Let me answer the question. So these core samples are taken at certain depths. Let me check this. So it is taken at this depth. Can you see the bin?
Yeah, I can see it.
The samples are taken at certain depths, but we want to predict like the porosity here, the porosity here, the porosity here, in order to get a continuous log, or to predict the core porosity in wells that have no core data, based on the wells that have core data. Do you
Okay.
get what I mean?
Yeah.
We are trying to build a model to predict another data.
Okay. Okay. I see that.
Okay.
Okay.
So basically,
I
we are
understand.
heading for like interpolation in the data where we don't have any kind of data available.
Yeah, exactly. But it is not only interpolation. There is extrapolation in the process.
Yeah.
In new wells.
Sorry, I've got a question.
Okay.
So you just mentioned that we're going to be finding the data with using machine learning. We find the gaps, and how do you find the gaps? So do we go through the historical data? I'm guessing.
What you mean by gaps?
So you mentioned the small gaps in the porosity. We'll find the places, and then we do interpolation of the
Yeah.
log. So
You have a
history matching of the
continuous
log.
log for the whole well. You have a continuous log for the whole wells, and the core samples are taken at certain depths. You need to have to predict the velocity, the porosity at other depths to have a continuous log. But you exactly have a continuous input. You are trying to predict a continuous output.
Okay, got it. Thank you.
Okay. Now we will go on. So here is the data that we have. We have the data. We will have depth, the deep resistivity log, the density log, the gamma ray log, and the compensated neutron log, the caliber log, and we will try to predict the core porosity. So the inputs will be the open hole logs, the outputs will be the core porosity. We are trying to make a model that captures the relationship between them. Okay. So how supervised machine learning work, and what is the supervision in this? So you have inputs. Let's think as a simple equation, y equal f of x. So you have inputs, which is x, and you have output, which is y, which is called the label. The inputs will be the open hole logs, the outputs will be the core porosity, okay? Which is called also by a target, a label or a target. So you are trying to find this function, so that given any x, you can predict the y. Think of it as an empirical, you are building an empirical correlation based on some samples in order to find a continuous prediction for the output. So this function is represented by the model. The model now, after training, understand how to map from X to Y. What is the supervision in this? It is the label. The target itself, it is like that the human tells the model when given X, the Y equal like 1, 2, or 3. So the human gives the model the output, and it will ask the model the output on data that it haven't seen before. So this is a concept of supervision in the supervised machine learning. It is a label. According to the type of the labels that you are trying to predict, the supervised machine learning can be subdivided into two main categories: the regression or classification. If you are predicting a continuous variable like the pressure, the rates, the prices, then it is a regression problem. You are predicting a continuous variable. It is like 1, 2, 1.5, 1.6, 1.5, and so on. The classification, you are trying to predict discrete variables. It is like predicting the lithology. The lithology can be either sand, shale, limestone only. or classes like variables. Now we will understand how this process is done. So basically, you have data. This data consists of X and Y. All of this we are talking about only the supervised machine learning. So you have X and Y. You give this X and Y to the machine learning. And now the machine learning model will be trained on this data in order to find the function between the inputs and the outputs, or between the input and the label, or the label also can be called as a target. After this, now you have a trained model. The trained model now represent the function. You will give it the inputs, the open hole logs, and it will predict the output, which will be the core porosity. So is it clear?
So just for my understanding, so basically the function or what we're teaching the machine, the model is the steps of finding out the porosity. Is that correct? So that in
Yeah.
future, if you give him any random data, or and he just uses the same steps and calculates for us.
Yeah, we will practice all of these steps. I'm trying to make sure that you understand the slides, because I will apply exactly the workflow inside the software. The
Thank
workflow
you.
will be exactly the same.
Thank you very much.
Okay. Now let's go on. This is simply what is supervised machine learning in a nutshell. Okay. Now let's talk about the general workflow that we will apply exactly in the workflow. So you have data. Just to recap, you have data, you give it to the model. The model now is trained, and the model now is ready to produce output on a data that it have never seen before. So according to the types of data that I mentioned earlier, it is either structured or unstructured data. The structured data, from its name, it is structured in a certain way. It is a tabular data. It is like Excel files, CSV files, rational database, any table-like data. The unstructured data are the images, the audio, the text. Those actually are more related to the LLMs applications, or what you can actually call AI, not machine learning. It's actually called machine learning. I'm sorry for this. So for the steps, you need to define your problem. You need to collect the data. You need to do data pre-processing, but we will not do this. You need to train the model, and then after training the model, you need to make sure that the model is not hallucinate, that the model actually predicts reliable output. The output from the model is actually correct in order to predict like the value in new wells. Okay. So what I mean by defining the problem can be supervised or unsupervised or reinforcement learning. For the supervised, we examine that it is subdivided into classification or regression according to the type of Y that we are trying to predict. Is it a continuous variable? Then it is a regression problem. Is it a discrete variable? Then it is a classification problem. We will not talk about the baseline. Oh, let me just explain something here. To actually have a real value from any model that you produce, there must be some solutions that exist in the industries that do the same work. It is like building something to do something that there's a commercial software that do the same steps. What is the value then of the machine learning model? Either it has better performance or lower time to produce the same output. Then there is an added value. So you have a baseline that you need to beat to be a successful project. Now I'm talking about the real life. So you need to define the problem. You need to collect the data accordingly.
أظن شي training.
موافق سه.
Can you please mute your mic? I don't think you speak to me. Okay, you need to collect the data accordingly. You need to pre-process the data, train the model, and then evaluate the model. So we have collected our data. We have defined our problem. It is predicting the core porosity. It is a continuous variable. Then it is a regression problem. We have collected the data, which is there are core samples at certain depths, and we have the open hole logs. So we combine the data into an Excel file. Then after collecting the data, we will not do actually this step in the software, which will be data pre-processing. What kinds of pre-processing actually you can do? If there is missing data, actually the data that I will provide is very clean. If there is missing data, if there is irrelevant data, if there is outlier, you can actually have core samples that it is actually doesn't make sense in the context of the well or in the context of its position in the reservoir. It's like the average porosity is 18 and it is 30%. It doesn't make sense. Or you need to investigate this. This is what you can imagine as an outliers or anomalies. There are feature engineering, like deleting features, adding new features from existing features, grouping features. There is something called feature engineering that what I need you to remember. And there is data transformation. Some of the machine learning model, it's a must step to do data transformation, like normalizing the data or encoding, decoding the data. You can investigate more on these steps, but I will not apply them actually in the software. Also a step here is you have the whole data set. We said that we need to train the model and then evaluate this model if it actually produce reliable output or not. So we have the training data, we have the whole data, we will split it into two parts. We have the training data, which will be used to train the model, and we have the testing data, which will be used to test the model itself, to see if it is producing reliable output or not. So this is the workflow that we will do. We have the data, we will split it into training and testing sets. The training will go to the model in order to be trained, and the testing will go to the evaluation step along with the model to see that if the model performance is good or not. Is there anything unclear until here? It's normalization. Normalization have a lot of meaning according to the context. It is like you can call it sometimes data scaling. It's like if you have values, I will explain only a certain type of normalization here. It is like if you have values between 100 to 100, 3,000, what? 3,000. What is happening? Sorry, 100, 200, 3,000, 500. A term of normalization here is scaling this data to be between 0 and 1. This is called min-max scale. Another type of data normalization is to make this data to have an average of 0 and a standard deviation of 1. Why do we even need to transform the data like this? For like supervised, unsupervised machine, let me explain this in the step of unsupervised machine learning, but I need you to remember there is min-max scalar and normalization to have a mean of 0 and standard deviation of 1. Okay, I will explain it in the unsupervised. Just remind me if I forgot. How to evaluate the model in the evaluation step? As we said, we will split our data into training set and testing set. The training set will consist of the X and Y. We will give the X and Y to the model. And the testing set will contain only X. It actually contains X and Y, but we will give the model after it has been trained only the X, and it will produce Y. And for the same data, we have the actual Y. So we have the model outputs, and we have the actual values that the model need to produce. Okay, so we have the model output, and we have the actual values. And in regression problems, the matrices are pretty simple. It is the mean absolute error, the mean squared error, and the root mean squared error. It is elementary level statistics, so I don't think anyone have a problem with this. So the lower the mean absolute error, the better is the model. Let me just explain this. If it this the residuals. Let's say if this line represents the actual value that the model need to produce, and this is the model output, okay? This is the residual between the model output and the actual value that it need to produce, and this is this term. Okay, if you have multiple values, then you will compute the residuals to have a mean value of these residuals over all the data. There is actually some sort of visualization of the model performance is to plot the model output versus the predicted output on a linear scale, so that the more the data are confined to this straight line represents that the model output predicted, it is like the model predicted 3,000. Then the true value need to be 3,000. The more the data are confined around this line, the better the model performance. If the data is scattered around this line, around this straight line with a slope of 1, then it has a lower performance. Is this matrices are clear or not? The data that we use for the evaluation are not the same used for the training. Yeah, exactly. We will use data that the model haven't seen before. I was disconnected due to notation. Okay. Is these matrices are simple? I guess the mean absolute error, we all know the mean absolute error. Okay, just to recap, the mean, or let's return back. What is the mean absolute error? So we have, if this is the model output and this is the actual value, we will take the difference for each sample. So let's say if the difference here is 0.1, the difference here is 0.2, the difference here is 0.01, the difference here is 0.1, the difference between this and that, the absolute difference, not the model output minus the actual value. I mean the absolute value, and you will compute the absolute difference between these two samples, and then take the average of those values. Then you have a mean of the difference value between the model output and the actual values. Okay. Actually, I always forget to insert this matrices. The mean absolute percentage error. What it means here, we compute only the difference between the actual and the predicted value. But how is this difference is compared to the actual value? It is like if the actual value is 1,000 and the predicted value is 900, and if the actual value is like 3,500 and the predicted value is 3,400. Can anyone tell me what is the best between those? If this is the output between two different models, this is model 1 and this is model 2. What is the best model between them? The difference here is 100, and the difference here also is 100. Model 2, model 1. Both. The difference is exactly the same. Okay. For the ones who said model 2, they are correct. Why? The difference here is 100, but compared to the actual value, it is significant. It is like 100 over 1,000. It is not the same as 100 over 3,500. Okay? Compared to the actual value, this difference is not significant enough as this one. This is the mean absolute percentage error, which is the absolute error between the actual minus the predicted over the actual value. Okay, is it clear? Is this clear? Okay. Let's go to the second point. So let's just recap. We have the data. We will split our data into training and testing data. We will train the model on the training data, and we will test the model on the testing data. Now let's jump into the software to do exactly the workflow that we mentioned. This is Orange data mining software. I will provide the link. Can you see the screen of the software? Can anyone tell me?
Yes.
Yes.
Okay, so it is Orange data mining software. I will provide the link to download the software for you.
Is it
It
an
is
open source
graphical user
software?
interface. What?
Is it open source?
Is it what?
Open source.
Open source, yeah, exactly. Open source and free. Okay. How it works, you have widgets. Let me use the pen. We have widgets on the left side here. You will use those widgets to build a workflow where the data is connected here. So you will use those widgets. Each widget or each icon will do a predefined step. So you need to connect between those steps. Let's start by importing our data into the software. So we have a code file. We'll drag it, or we can simply open it. Okay, and here is a preview of our data. We have 9 columns, a column called well, a column called the depth, the deep resistivity, the density, the gamma ray, the compensated neutral log, and the code. Here is a very crucial step. You need to make sure the data type is and relevant to you. So the well is categorical. We have two wells, well 1 and well 2. Okay, it is categorical feature. The depths, from the depths to the core porosity, they need to be numeric, and they are imported as numeric features. If they aren't imported as what you want, you can change it from here. Okay, it is numeric, and then apply. Now we need to visualize our data into a table like. So we will drag, we will press here, drag the line, release the bottom, and then select data table. Now the data is transferred from this widget, which is called the file, into the input of the data table. From this represent the output, and this represent the input. Now we can see our data into table-like format. We have two wells. We have the data, the input data that we need, and the output data. What can we firstly investigate in this data? As I think, I need to see the distribution of the pool porosity that we are trying to predict. So I will take the output, which represents the data from data tables, into a widget called distribution. Can you see the data flow? It flow from here to the input of here. And I will take the output of here to the input of this widget. This widget is used to show the distribution of any feature of your choice. So I can increase the bandwidth, so I can see here there is a high amount of data which is labeled below than 0.06%, and there are a small amount of data that is have high porosity, like higher than 2.5 or 25%. But I need to dig deeper into this visualization. I need to see the distribution for each well, so I can understand which well is have a good reservoir than the other. I can split the distribution. Okay, now I can see that the distributions, each one is colored according to the well. So the blue represent well 1, the red represent well 2. From what I say, I'm sorry, the average porosity for well 1 is higher than the average porosity of well 2. But it is actually vague here to see this difference. We can actually fit a distribution to each well. This is a normal distribution, so this should be the average value, and this should be the average value. So it is actually the average value of well 1 higher than well 2. But it is still very vague here to see this. Is there any better visualization to see this difference? Yeah, there is. We can take the same data to make box plot. So it will remove also. So I subgroups I will. Now it tells me that the mean porosity for well 1 is like 14%, and the mean porosity of well 2 is 12%. So well 1 have higher porosity, or generally higher porosity than well 2. Anyone understand these plots? So you all understand these plots? My voice is breaking. Since when? Since when? From what step? Yeah, I got you. So my voice was clear, or it was actually breaking? No, it becomes clear now. So it was breaking, like what Fadi said. Okay, just tell me in the box. Okay, thanks. So just tell me in the box when something like this happen again. But we got your point. Thanks. It's okay now. What this box plot? If anyone don't understand what is a box plot, what this plot say is that this represent the median value. What is the median value? The median value is the value or the percentile, the 50% percentile. Now I am making things harder. Let's simplify. Let's say we have data like this: 2, 3, 5, 1, 4. To get the median of the data, you need to sort the data first. So to be 1, 2, 3, 4, 5. And the value just in the middle of the data, this is the median. The median is the value that is just in the middle of the data. The mean is just the sum over count. So we all know the mean, but the mean is just the value in the middle of the data. If we split the data into two parts, like this is part 1 and this is part 2. So this is the median. That split the data into two exact parts. This is part 1 and this is part 2. The part 1, this is the median of part 1, and this median of, I wish it is clear, but I don't think so. So what you can get from this to simplify is that 50% of data is between 10% and 15%. And here, 50% is between 10% and 17%. Okay, I wish I made it clear. Is it breaking? Voice not clear? I see there is a problem in the voice. So can you hear me now, right? Can you hear me well now?
Yes.
Yes, we can.
Okay. Do you understand the box plot?
Yes.
What is the most common data mining using? What is common data mining? I don't understand the question. So let's move on. We can also make a scatter data to make scatter plot. We can make a scatter plot like between the gamma ray and the poor porosity, and you can do your own visualization to understand the data more better. So now let's jump into the machine learning step. Now what we will do, have the data, we will determine the inputs and the outputs to the model, and some of them that the model didn't see to the model in order to evaluate it. We will take the data here from this table. The connection is unstable, so I will just wait. Now it must be clear. And the output. So I will use those features at the inputs, and the output. Okay. After this, we will split our data. What is the widget that split the data? It is called a data sampler. So we will take 90% of the data as the training data and 20% left for testing the model. I will drag a line from this data sampler to give it to like linear regression. Now this model is given the 80% of the data to be trained on. Okay. And then take this model to something called the test score, which is visualized in the slides as the evaluation step. And I will give it also the remaining data. Here you can double click on the line to say that no, I don't know, I don't want to send the data. I want the remaining data, which represent the 20%. Now this widget have the model trained and the 20% of the data. So we now have model output and we have the matrices for the regression problem, like the mean absolute error, the root mean squared error, and the R square. We can actually visualize the model performance, as we said, by plotting a scatter plot between the predicted and true value by dragging line here, scatter plot. What will be the x? The x will be the core phi, which was the actual value, and the linear. Now we can see that the model is doing a very bad job. Okay, data is very scattered. Until now, is the workflow clear? Please tell me about the deep resistivity. It is exactly what I animated in the slides. So is it clear? Okay.
Hey, hello.
Okay. Yeah, I can hear you.
Okay, where you had to split the data into
I can.
testing data and the
Okay.
testing data and the which other one?
Okay. Okay. I got your question. So let's get back here.
No, actually
Let's
not
just
this one.
remember this visualization. I know, and I will repeat what I did in the software, but I need you to remember this visualization. Let's get back directly to the software. Here, we selected the inputs and the output, okay, by a widget called select columns. The data sampler here do a job, which is splitting. If we have the data like this, it split the data according to the proportion that you determine. Okay, here I determined that I need to split the data by 80 and 20%. So if the data is like this represents the 80% of the data and 20% of data. Okay, until now?
Okay, that's good.
So from this widget, we have two outputs. We have the 80%, which go to the linear regression model, and the 20% that the model wasn't trained on have gone to the test and the score. So now we give the 80% of data, which represent X and Y, which contain X and Y, to this linear regression model. Now it is trained on the data. And we will take this model with 20% of data that have X and Y also, but the model will predict the Y, and we will compare between the Y produced by the model, let's call it Y hat, and the actual Y. Okay? Mahmoud, is it clear now?
Yeah, it's clear.
Okay, can you hear me?
Yeah, I can hear you.
Okay, now becomes good, but I have a question, please. What we gonna do after we know that the model output is not okay, or is not, the quality is not okay?
Uh, that's that was the next steps that I'm going to do, which is investigate another machine learning models.
Okay, great. Okay, thank you so much.
You're welcome. So now we know that from the matrices, from the points, if they are confined to a line or not. Now the connection is not stable. So now we will try to investigate another machine learning models. So this is only we can actually give the same data to another model, let's say a random forest model, and we will give the model also to the test score. It will compute the matrices for the new model, and now we have the linear regression model in terms of matrices. Even the R square is now 84%. We can actually visualize also the output of a random forest using the same workflows that we built. We only added a machine learning model, another one. So we go to the scatter plot. Okay, now the x-axis represents the true value, and the y-axis now I will choose the random forest. As you can see, it is much better unless some points is scattered. We can actually show a regression line between this data. It is much better than this. Okay. We can add more machine learning model and investigate more and more. We can actually add like the gradient boosting and give it also to the test. We can go directly to test score to test the model output. 83%. The random forest and the gradient boosting are tree-based models. Okay, so as I said, I will not go into details of how these models work. Let's see the gradient boosting. It is actually doing a pretty good job also. So actually that's it to simplify the concepts for the supervised machine learning section. Is it clear? Is there a guideline for selecting what part of data do you use to train the model and what part? Same question. Okay, this data sampler is selecting the data randomly. Okay, it is like I have 100 row. If I have 100 row inside my data, I will select randomly 80 row and 20 row randomly in a random manner. So this represents 80% of data and this represents 20% of data. Does this answer your question? What ES means? Randomly, okay. Yes. So that's it for the supervised section. Now we will go to the unsupervised, which will be much shorter than this. So is it clear? I will only wait a minute. Okay.
Can you hear me?
Yeah, I can hear you.
Can we go a little bit steps earlier for the data visualization part? Like you mentioned, the scatter plot distribution and the box plot.
Yeah, which one?
Yes. Can we go to the distribution part?
The distribution part.
Okay. Well, in this data visualization, we used the normal curve to show which will is doing much better. Okay. My question comes here: what if there was conflict between the columns here? Some of the columns show that actually for the blue one, for the well number one, it shows a high frequency in the core value of 16%, while in the well two it shows a high frequency, a lower frequency. On the other hand, the normal curve shows the average porosity of the well two is much higher than well one. In this case, how can I evaluate which actually one is better from the two wells?
I can see, I understand your question, but I actually followed a sequence of thinking. So I visualized first the distribution, trying to know the difference between the two wells to understand the distribution of each well. And I said, from this, I cannot actually determine, and it is pretty vague. Is there any better visualization to determine this? And that's why I have gone to the box plot. It is much more better for this task.
Okay. Okay.
It's
Then we are
you follow a logical thinking. Just
okay. Oh. Mhm.
okay.
So the box plot method in data visualization shows which actual one is better in performance with the core prosody, right?
Yeah, it showed the actual comparison that you can actually now compare between them. But here is a point that you can actually okay, it is now better. If we now compare between well 2 and well 1, where the 50% of data lies, as we can see here, this range is shorter than this range. What this tell us? Can anyone answer?
There is no much heterogeneity in
In well 2.
in the will too. Yeah,
Yeah, exactly.
we're talking about a smaller range of values.
Yeah,
So it's
exactly.
okay.
Right. Good answer. So from this, you can actually visualize the distribution of data and how narrow and wide are the data. The well 2 have higher standard deviation, and the range of the 50% of data is much higher, which show higher heterogeneity than well 2. So Mahmoud, you raised your hand. It will be the last question.
Okay. I have a question here. When we got the two different values of the median and the average values, so in the practical life, where we can use each one of them. I mean the median and the average value.
For me, I will use
Yes.
the median and mode.
And why?
It is much more representative for this distribution.
Okay. 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 Thank you.
Let's answer your question in more practical manner. If we have the distribution of data, if it is more normally distributed like this will be the mean, and it will be exactly if it's perfect normal curve, the mean will be the same as median will be there for the connection, with which the value that has higher probability. So if the data is skewed like this, the mean will be here. It will be the mean. And the median and the mode, the majority of the data points, the values at the higher probability section. Okay, the box plot for this distribution will be like this. Okay, and now this is the median. Can you understand what I mean now?
Yes. It becomes
It is
clear.
much
Thank
more
you.
representing the distribution of the values.
Okay. Great.
Okay.
Thank you.
As I said, this will be the last question. Let's get back to the slides. Now let's go to the unsupervised machine learning. As I said, in the supervised machine learning, we have X and Y. You have only a data set that contain columns. The unsupervised, consider it as a predetermined workflow that you will need to follow. So from its types, there is clustering analysis, there is association analysis, there is dimensionality reduction. Okay, it's predetermined workflows that you will only follow. For clustering, it is like you have the continuous values. Let's say now you have continuous value for the prosody from the supervised machine learning model. You need to classify these open hole logs in order to have like electrophages. They call it electrophages because they are based on the electric logs. Okay, So now we are doing just clustering. So it is like this. This interval is much more like this interval. And this interval is much more like this, and so on. You are clustering your well into like different electrophases. There is no label, there is no target, there is only X that will follow predetermined workflow. It can be customized, but the workflows or the main target will be one of the three: clustering, association analysis, or dimensionality reduction. There may be something else that I have dropped, but those are the major. So we have discussed the clustering. What about dimensionality reduction? What is dimensionality reduction? The concept of dimensionality reduction is like this. Let's say you have this 3D visualization of a bicycle. You need to draw this bicycle in two-dimensional space, but the sketch need to be more representing the actual 3D space. Can anyone tell me what is the best representation of the 3D bicycle into 2D dimension? Left. Yeah, exactly. So this is much more better representing the actual 3D data than this. It have more information, more info. So this is the idea of dimensionality reduction. Dimensionality reduction is basically you have high dimensional data set. It is like you can have like hundreds of columns, hundreds of variables. The variable here is called the dimension. So if we have data set of 5 variables, it will be 5-dimensional data set. So now let's say we have 10-dimensional data set. We need to compress this and create new columns that will be only 3 columns. We need to convert this high-dimensional data set into only 3 columns, and still those 3 columns will preserve most of the information of the 10-dimensional data set. If you forget it, just remember the bicycle example. You need to draw the data into lower dimensional space and still preserving most of the information in the high dimensional data set. Let's actually go back to the software trying to do some clustering. So I'll move this a little bit.
I'm just reminding you about the normalization. You asked me to. Okay.
Yeah. Thanks. So we will we'll select some columns. Here, the unsupervised, we have only X. So we just drop the well, we have all the data. Okay, the open hole log and the core data. We will take this and try to project this data into two-dimensional. I will wait. We will try to project this data into two-dimensional space and still preserving most of the information. I will use a widget called Disney. We'll open it. It is actually running. So this step is projecting the 5-dimensional data or 6-dimensional, 7-dimensional data set projected into two-dimensional space, which is basically the X and Y, while preserving information of the data and the relationship between the points. you can actually visually cluster those points. So this can be a cluster. This can be a cluster. This can be a cluster. This, and this. And this can be a major cluster. You can visually actually cluster those data. X and Y. Data set, it is like 1, 2, 3, 10, 12, 13. The other data is like 100 to see the difference in the scale of data. It is like when you visualize it into X and Y, you will have the X narrow here. Yani you will have most of the data here in X, and Y
We
can
lost.
vary on the.
Sorry, but we lost your
lost the
screen.
connection.
Yes, and the voice actually. So can you repeat the last part?
Yeah. Okay. So now you can hear me well and see the screen. Can you hear me well?
Yes, much better now.
Is anyone there?
Yes,
Okay.
it's much better now.
Just open the mic and tell me, so that I don't lose the attention. Let's say if we have two values like 1, 2, 10, 9, 8, 12, 13, and so on. The Y is like 100, 200, 600, 800, and something like this. If we visualize
Again, your voice is
on
breaking. Yes.
scatter plot, it will be like this. You have here, it keeps sitting out. Your voice is gone. But there is actually no problem in the connection. So I will be for the third time. We have X values and we have Y values. The X values between range 1, 2, 3, 4, and the Y values 1. Still can't hear me? I guess there's problem here. Audio is very good.
Your voice is breaking actually.
Yeah, I can hear. I can see from the comments. I'm sorry. So it is much better than this. I'm sorry for this. Can you hear me now? I wish it is better.
Yeah, it's better now.
Okay, just tell me when it is lost again. So let's say for the purpose of explaining scaling and normalization, we have X values like 1, 2, and 3, and 4. We have the Y values 100, 200, 300, and 400. If we visualize those points on an axis, it will be like this. Most of the X values will be here, and the Y values will be scattered here. So what normalization do? is that normalize the value so that X and Y have the same scale or the same range. So that for X, for each point of X, let's say that Xi, we will Xi equal the X minus the mean over or the minimum, X minimum, X max minus X minimum. I don't know why it is bigger now. I'm sorry. I will just normalize the X values to be between 0 and 1 and the Y values to be between 0 and 1. How to do this? For each point of X, let's say Xi equal to the value of Xi minus the X minimum over the X maximum minus X minimum. And for each value of Y will equal to the Yi minus the Y minimum, the minimum value from all Y's over the Y maximum minus Y minimum. Applying this equation to each value in X and each value in Y, the points will be normalized to be like this. This is 0 and this is 1. This is 0 and this is 1. If you revisualize the data on X and Y plot, it will be much more distributed throughout the space. Let me ask this. Which one is better for like clustering analysis or clustering the points? Which one make the points more differentiable than the other? Using the data as the same or the normalized one? The normalized one. So both of them have the same space and they are more distributed throughout the space. So it is much more better or it is a must for the clustering to normalize the data or call it scaling the data. So is it now clear?
Yes.
Okay. So let's get back. We have projected our data into two-dimensional space, but this is actually for visualization. We can do k-means clustering without even do this. We can actually take data. This is like k-means. K-means is the model that used to cluster the data. Okay. I will say I will cluster the data to have 3 clusters, or I can make it cluster the data with a range of clusters. As in practice, I don't know the best number of clusters for the data. So I tell it, try from 2 to 8, or try from 2 to 10, and tell me which one is the best. So now it tell me that this is a Saluto score. It is a matrices for unsupervised. I will not go in this. So we will just follow these basics. It will take time. So we'll just keep going like this. This Saluto score tells me that 3 clusters is the best clustering for this data that you provided to us. Okay. So now I can go and fix the cluster to be 3. We can actually take the data after clustering to make like a scatter plot. We can make a scatter plot like between the gamma ray and core phi and color these points based on the cluster classified by the k-means. Okay, we can do this between each kind of data. I feel bad for not the Saluto score, but it will take time. So this is for the clustering. Is anything unclear? Just tell me. Okay. Let's say after clustering the data, you need to save your outputs with the original data and the clusters based on the key means clustering. You can take the data from here, like save. I will save it, save as the desktop or data set. We can go to the desktop and have the data. Here are all the columns. Where is the cluster? And here is the cluster. C1 represent the cluster number 2, and C2 represent and C4 and C3 and so on. After this, you can actually investigate those clusters. It needs domain expertise to visualize these clusters along with the open hole log, and does they make a sense or not in terms of petrophysics? Do they actually split the points? Like cluster 1 actually represents the sand with my analysis as a petrophysicist. So I will use C1 as the code for sand. The C2 are more related to the shale, so I will use it for classifying the points as shale, and so on. Is there any question?
So how long this seminar webinar will go? How much time?
This is actually will be the end.
Okay.
I will provide the data for you, and I will provide the slides as a PDF, and I will give you the links for downloading the Orange software. So let's get back to finish this. So just to recap, we have artificial intelligence, that is the major set. Machine learning is just a subset of artificial intelligence that focus on the computers performing tasks without explicit programming. They learn the rules from the data itself. The deep learning is a subset of the machine learning in which the models are basically neural networks. So just to end this webinar, when and when not to use machine learning, when it will have a value and when it will not have a value. Don't do machine learning if you already know the rules, that if you have X and Y and you know what are the equations that produce Y correctly, then why to use machine learning? Okay. But you can do machine learning when you don't know the rules. So you have inputs and outputs and you don't know what are the rules behind. It is like if there is an example of email classification. You have emails, some of them classified as spam and some of them classified as not spam. So, but you don't know how they are classified as not spam. You don't know what is the pattern behind the spam emails. You will give it to the machine learning model and they will learn the pattern. Or when you cannot scale, assume that you can manually identify the pattern of the spam emails, but it is like you have 1 million email to classify. It will be very time consuming and very overwhelming to any analyzer. You can just give the data for machine learning to learn the pattern, and they can do this in just in a matter of seconds. I like to give this example. Machine learning is not a solution to any problem. It is not like this, is that you have a problem that you need to solve, just say the magic words, machine learning, and the problem will be solved. It is not like this. At the end, this workflow was based on a graphical user interface without writing any code. But at some point, it is very well, and it is very good if you are prototyping. Prototyping, you have a small data set very limited visualizations, and you are prototyping using some source, comparing between the models. You are very good with the visualizations inside the applications and so on, but at some point you need to go to Python. With the current tools, the AI tools, ChatGPT, Grok, DeepSeek, and so on, you can actually write a lot of programs without knowing actually what is programming. But at some point you will get stuck, and because you don't know the basics, the chatbot or the AI model will hallucinate, and it will be a very bad mess because you don't know how to validate the AI output. At some point you will get stuck. And using Python, you can create your own applications, your own programs, and it is much more flexible and expandable than the graphical user interfaces. So that's it for today's webinar. I will see the chat.
Thank you.
You are welcome. No, it is not. This is for supervised. To answer Fahd the question, machine learning is used to find a function. No, it is not like this. It is the supervised section. The unsupervised, there is no function. You only give the data to a predetermined steps to make a certain analysis, like clustering analysis or dimensionality reduction. Okay?
Okay, got you. Thank you.
You are
Thank
welcome.
you very much, sir.
The software is Orange Data Mining, and I will provide the link to download it for you. You are welcome, guys. I appreciate your comments. Thank you.
Thank you, Mr. Ahmed. Thank you, everyone who joined our webinar. We will send your certificate about attending webinar in few hours or on few days from now, inshallah. Mr. Muhammad, you can ask what you need, Mr. Muhammad. Mr. Muhammad, you are raised your hand. Are you need anything? Okay, thank you again. Uh, and thank you, Mr. Ahmed, for this interesting webinar.